Okay, we are starting chapter 8 and we are going to be dealing with polynomials this time. Let's see, I'm sorry, I'm just trying to get this all figured out. Okay. It says we'll write polynomials in standard form and add and subtract polynomials, but you're going to want your notes handy and you're going to probably want to pause this video a lot and take some notes because there's a lot of terms and things that might be new. So here is the vocab. Polynomial is just a broad general term for all. We talked about monomials, okay? That's your one term polynomial is just a monomial. That's like your 3x squared. And then a binomial, like a bicycle, is two terms. So monomial is one term, binomial is two terms, and that might be something like 2x plus y. Okay. And a trinomial, of course, is three terms. So we might have 5x squared plus 2x minus 6. That's a trinomial there. And those are the ones we're going to be talking about a lot. And then we'll talk about the degree of a monomial, which you know how to do because we did this. It is just going to be all of your variable degrees added up. So I'm going to do a couple examples real quick for the degree of a monomial. And the degree of the monomial, so if I have 5x to the 5th, y to the 6th, the degree of this monomial is 11 because I have a 5 and a 6. And it's only the variables because the degree of a constant is 0. If I had negative 2x y to the 2nd, the degree of this is going to be 3 because x is 1, even though you don't see it, and y is 2. And this one has a degree of 2. The degree of a polynomial is you just find the degrees of each monomial, and the highest one is the degree of the whole polynomial, and we'll practice that. And yeah, we'll get into the rest of those as I go through the lesson. Okay, so to identify polynomials, the things that you are not polynomials. Okay, so I'm going to write, and I know you guys took notes on this, but I will just refresh your memories. So not is if you have a variable in the denominator, like 2 over x, or if you have a square root of x, or if you have a negative degree or a rational degree, like a fraction. So if you have x, okay, that's not even an x. I'm going over here. An x to the negative 5, or x to the 1/3. These are all not polynomials. Okay. If I think of others, I'll add to them. So what we're going to do is determine if something is a polynomial, and if it is, then we're going to find the degree and decide if it's a monomial, one term, binomial, two terms, or trinomial, three terms. Oh, they just give you the answer. Great. Okay. So this one is a polynomial, and there are two terms. Terms are separated by plus or minus signs, okay? And this term has a degree of 1, and this term has a degree of 0. So the highest is 1, so that's where they get the degree of 1, and it's a binomial. Here's one that we have 3 terms, so it is a polynomial, and it's a trinomial. The degree of this term is 2. The degree of this term is also 2, and this is, of course, is 0. So 2 is the highest, so that's why 2 is your degree. Okay, this one's not a polynomial, and it's because there's a variable in the denominator. So when it's not, you can just write no. This one is just one term. The degree is 2, so it's a monomial. All right, you get to try this one on your own. You can pause it. it is a polynomial, and it's a trinomial because there's three terms here. We have this one, and this one. And if I asked for the degree, you would tell me 2, because this has a degree of 2, this has a degree of 1, and this has a degree of 1. And 2 is higher than 1, so we go with 2. Okay. You can do this one. Oh, look, there's a negative exponent, so it is not a polynomial. Here's another one. This one is 2 terms. It is a polynomial, so it's a binomial. This is yes, it is a monomial. All right, standard form is where you have to take the terms, the degrees have to go in descending order. So essentially you figure out the degrees of each term and then you go highest to lowest. You just rearrange it, okay? And then the one with the highest, the one that will be in front, is going to have a leading coefficient. So this term has a degree of 2, this has a 6, and this is 1. So I'm going to put the one with 6 in front. So I have a positive 3x to the 6. Then I have a positive 9x squared. And then I have the negative 4x. Okay? So this is in standard form, highest to lowest degree. The leading coefficient is the coefficient that's on the highest term. So the leading coefficient is 3. Here's another one. Let's take a look. The degree of this term is 0. This one's 1. This one's 2. And this one's 3. So we'll start with this one, then that one, and so forth. Okay, so we have 8xy squared plus 6xy plus 5y plus 12. Okay, and then the leading coefficient is just going to be 8. All right, you can do this one. Hopefully you got A. And this just says to identify the leading coefficient. So in your head, you can put which one's the highest monomial or the highest term and look at the degree, or I'm sorry, look at the leading coefficient of it. Okay? You should get 8 because this term right here has a degree of 4, whereas the other ones, this has a 3, 2, 0 here, and 1 here. All right, now we're going to add them. And adding them is really just combining like terms. So you don't actually need the parentheses. So you can just imagine them dropped. And you just find your like terms. Remember, like terms are the same variable to the same degree. So I usually start with the highest because then it's already in standard form when I start writing it. So I have a 7y squared and a 5y squared. Well, I got 12y squared. Okay. Then I have a positive 2y, and I'm adding a negative 4y. So I have a negative 2y. And then I have a negative 3 plus 2, so I just have a minus 1. And that's all you need to do for that one. The book will show like horizontal methods and vertical methods, and you can do whatever you want. I never actually do the vertical method, but you can do as you wish. All right, we'll add this one. Let's find the like term to 4x squared. Okay, it's negative 7x squared. So when I combine those, I have negative 3x squared. And then I have a negative 2x and a positive 3x. So that just leaves me with a positive 1x. And then I have a 7 and a negative 9. so I can just combine those to -2. There you go. And if I asked you what the leading coefficient was on this, on the one that I wrote, it would be -3. Okay, go ahead and try this one out. You should have gotten A. And here's another one. Notice your 4x cubed doesn't have any terms that it can combine with, so it just stays there. Subtracting, you have to distribute that negative before you can combine your like terms. So when we do this, we're just making that negative on each one of those terms after it. So it's just a -1 times a positive 9y4, -1 times a -7y. So this becomes a -9y to the 4th. This becomes a positive 7y, and then a -2y squared. And these guys don't change at all, but I'll just write them down. Okay, now we can just combine our like terms. So I have a positive 8y to the 4th and a -9y to the 4th. So I have -1y to the 4th. My next highest are 2's, so I have a positive 6y squared and a -2y squared, so I have a positive 4y squared. And then I have a -5y and a positive 7y, so that gives me a +2y. If I asked you what the leading term was, the leading term is this whole term, -y to the 4th. And if I asked you for the leading coefficient, you would tell me it's -1. Here's another one. And I'm just going to rewrite this right underneath it. So -4n, positive 3, and -5n squared. And then I combine. So I have my squareds here. 6n squared and -5n squared. Oh, I didn't even see this. I have an 11n cubed, so I'm going to put the 11n cubed first. And then I'll do my squared. So 6n squared plus a -5n squared is just 1n squared. And then I have a 2n and a -4n. So that's a -2n. And then all I have left is this positive 3, so I'll tack that on. There we go. All right, you can go ahead and try to do this one. Be careful of the signs. Should have gotten B. And another one. This time it's C. And I don't think I'm going through this, but there is one more little thing after it. No, there's not. Okay.